Hello friends, good morning. In this video we are going to learn about what KVL is, what is the derivation of KVL, how to solve any problem related to KVL, and what are the sign conventions are there, like passive sign convention and active sign convention, and at last we solve a workout problem. So lots of before going definition of KVL, let's see what is the meaning of voltages in any circuit. Basically there are two voltages. One voltage is voltage supply and another voltage is voltage drop. So let's see what does it means. Okay, so let's understand what voltage supply and voltage drop means. Voltage supply means if you go in the direction of current, then if the voltage is increased, then it means that element is supplying the voltage, means energy, because voltage and energy are related. So if I go in this element, so here I can see that here is negative, means here low potential, here is positive, means high potential. So current is entering from negative side, means low potential, and exiting from positive side, means high potential. It means that element is supplying the voltage, means supplying the energy. So here voltage is increased from negative to positive in the direction of current. So this supplies the voltage. And here the current enters from positive side and exits from negative side. So here voltage is decreased in the direction of current. So this element drops the voltage. Only one thing you have to remember, that if current exists from positive side, it means that element is supplying the voltage, and if current exists from negative side, that means that element is dropping the voltage. Let's back to the animation. Okay, as we know the definition of voltage drop and voltage supply, now we able to understand what is the definition of KVL. KVL basically say that the sum of all the voltages in a loop is 0. Here voltages means voltage drop plus voltage supply. So here we can see that a circuit, a simplest circuit, where 40 volts supply is connected and one 10 ohm and 130 ohm resistance is connected. So here we can see that if we go in the direction of current, so here 40 volt plus 40 is there, then here the voltage of 10 is dropped, and at last here the voltage of 30 volt is dropped. So we can see that in this whole circuit the overall voltage is 0, because here 40 supplies by this voltage source, 10 volt is dropped by this resistor, and 30 volt is dropped by 30 ohm resistor. Okay, now before going to another example, we need to understand what are things related to KVL. So first start with the derivation of KVL, then what is the steps required to solve any KVL, and after then we analyze this example. This is the best example to analyze. Okay, let's go. Okay, let's see the derivation of KVL from Maxwell equation. Basically KVL derived from Maxwell's third equation, which says that the curl of electric field equals to minus dB upon dt. If you don't understand this thing, don't bother about it, because we can write this whole equation in terms of in integral form, like closed line integral of E dot dl equal to minus d by dt of integration of B dot dA. This integration of B dot dA, this is flux density. If you integrate flux density over area, then you get a flux. So this is basically minus d phi upon dt. And you may have read that this term is voltage. So V equals to minus d phi upon dt, as you know from the Faraday law. So since in this circuit there is no alternating magnetic field, means here we are deriving KVL for only DC analysis purpose. So d of phi upon dt becomes 0. So this term becomes 0, and this closed line integral of E dot dl, we can subdivide this whole closed line integral. So if you see in this path, we can write that E dot dl from A to B, and then B to C, and then C to a, then it's become a closed line integral. This term and this term both are same, because here we are writing in just a closed loop, and here we divide this loop by simple elements. So now we can write that E dot dl from a to v as b1, because this indicates the voltage between E dot a and b. Same, this integral represents the voltage across b and c, and this indicates the voltage across c and a. So this is the voltage v1 plus v2 plus v3 equals to 0. And now in general term we can write this, that sum of voltage along any closed loop is equal to 0, and thus we derive the KVL for DC circuit. If you want to derive KVL for AC circuit, then we have to include this term, and this may be my another video that I will explain how to derive the KVL for AC circuit. Okay, now we can see the steps to solve any problem related to KVL. It is basically known as mesh analysis. So there are certain steps we just follow and we can get the answer. So first step is assume the direction of current. So if there is any circuit is given, you just assume your direction according to your mind. You can take any direction in any loop. Just I can take this direction clockwise, anti-clockwise. In most of the book they basically take clockwise direction in all loops, but you can take any direction. So first here we have to consider there are two directions are there. First one assumed direction, and second the direction where we go to write the KVL. When we solve the question we will see this all terms. So first step is cleared that we assume the direction. Here I am going to solve this question by first step. In first step I assume the direction in anti-clockwise and clockwise, and now first thing is covered that I assume the direction, and now I go in the same path where the current flow and they write the equation. So if I go from here, so I can see that I exit from positive terminal of voltage source. It means here voltage is increasing. So if there is voltage increasing, so I take this term as a positive. So here 10 volt I have written. Then I can see that when current enters in 10 ohm resistance, then here voltage will drop, voltage will decrease. So here 10 into I1, 10 is resistance, I1 is current. So 10 I1 will drop voltage. So I return this in negative 10 I1. Then when current enters in 5 ohm resistance, then here we can see that here two currents are flowing. One current is from upside to down and other is from down to upside. So here the difference of current flows in 5 ohm resistance. So here the drop will 5 ohm, which is resistance value, and the current flowing through it is I1 minus I2. So this is the whole equation of first loop. So after simplifying it, I can write this is 15 I1 minus 5 I2 equal to 10. Now try to write the equation for second loop. Here I start with 20 ohm resistance. Here first thing I assume the direction in this way, which is our one part is khata, one part is done, and second I am also going in the same direction in the current flow. So as we go from this direction, I can see that from 20 volt the voltage is dropping because I am exiting from negative terminal. So here minus 20 is written, and then when I comes here, then I can see that here the difference of current is flow. But one thing we have to remember that the loop which we are going, the current in that loop is dominating. Means here we can't write minus 5 I1 minus I2 because here I2 is dominating. So I can write I2 minus I1. So here minus 5 I2 minus I1, and then the drop in 10 ohm is minus 10 I2, which is equal to 0. So after solving this, we can write this equation, and from this two equation and two variable, we can get the value of I1 and I2, which is equal to 0.25 I1 and I2 equal to minus 1.25. Now if anyone is taking the current direction according to him, let's solve this question in another way. I take I1 in this direction and I2 in another direction. Now write the equation. First here 10 volt, so 10, this is supplying voltage because we are exiting from positive terminal, so here voltage is increased, so 10 volt minus 10 I1 because here voltage is dropped, and here the summation of current flow in 5 ohm resistance, so here minus 5 I1 plus I2. After solving this, we can write this as 15 I1 plus 5 I2 equal to 10. In second loop, if we write equation in the direction of current I2, so I can see that current is flowing from this direction, so here we exit from 20 volt terminal, so here voltage is increasing, so 20 minus here drop 10 into I2 because I2 current is flowing, so minus 10 I2, and here minus 5 I2 plus I1, which is equal to 0. So after solving these two equation, I get now after solving these two equation, we can see that I2 is 1.25, and in previous case I2 is minus 1.25 because here we assume the direction of I1 and I2 are different in both cases, so we get that result. Here negative minus 1.2, here negative 1.25 shows that the direction of assumed is different from the direction of actual I2. Both are opposite, that's why here negative terms comes, and here positive 1.25 shows that the both have the same direction. So I just want to show here that the KVL is not dependent on the direction of what we assume. It gives you the result. You can assume any direction whichever you want. Let's analyze the same thing in animation so that we can understand the KVL does applies in all places or not. Basically I want to say that here I apply KVL in this loop and this loop. In animation we can see that here we can also apply the KVL. Okay, let's see. Okay, now we can able to analyze the same circuit which have solved before. So here we can see in inner loop, like this loop, here we can see that here 10 volt is supplied, here 2.5 volt drops, and here it is 7.5 volt drops. So in whole circuit we can see that here 10 volt positive, here minus 2.5 volt, here minus 7.5 volt, means here total 10 volt drops, here 10 volt supplied. So KVL satisfied from inner circuit. Now see from from right side loop that here 20 volt is supplied, here drop of 12.5, and here 7.5 volt drops. So overall voltage drop is also 20 volts. So here also KVL. Now we can see that can we apply KVL outside the loop or not. Here 10 volt is supplied, and here 2.5 volt drops, so we have 7.5 remaining. Now here the voltage is increasing 12.5 volt in the direction of our assumed path. So here from this point we have total voltage of 7.5 plus 12.5, which is equal to 20 volt. And now here if we go in this direction, so here 20 volt drops, so overall voltage drop in whole outside the loop is also 0. So thus we can see that KVL applies in any direction, means any loop. That's all about the KVLs. Hope you like this video and subscribe my channel. Thank you.